already. In the multilingual crisis management, what we intended to do is to see how these LLMs can be implemented to enhance the response capabilities of the governmental institutions when responding to critical situations such as like terrorist attack or natural disasters. For doing this, we first try to look into what was the existing data, and we noticed that it's very centric to specific countries that they have developed these alert messages, but it's not available worldwide. So we augment that data with those examples for every country in the world, and also implementing different types of alert messages for natural disasters to wildlife. Then we use these alert messages generated with Cohere Plus, and we translated them to different languages using the Cohere and the two AI models. And we use the main Cohere, the Plus, as the reference for the blue mention marks that we will show later. And to finish the project, we develop a platform in the long term so volunteers can finish validating the quality of this translation, so we don't have to fully rely on the blue scores. You can move forward. Slides, yeah. So the initial result shows that for the human dataset, the blue scores was under 50%. But if we move one slide further, we can see that the synthetic dataset actually showed a much higher performance than the human dataset centric data. And it reached almost even 60% or 56% in the case of French language. If we move forward, we can see how this dependency, we notice that in the human dataset, there's a big fluctuation in the performance of the blue scores depending to the type of alert types. For example, severe unrest have a high performance in Spanish, but others have lower performance in other categories. And if we move forward, we can see that in the synthetic dataset, this situation is way more balanced, probably due to the fact that they have from the main data source, like the Cohere Plus. And if we move forward, we also wanted to see how this data is composed for. So we can move one slide more, and we can see the initial state of this human dataset, how it's being distributed in the two-dimensional space. And one more to see the synthetic generated data. And we see that the purpose of expanding this data into more knowledge, basically, it shows a good output. But if we move forward and we separate how this data looks into each individual category, we can notice different clusters. For example, in the wildlife, it makes sense that it's very centralized because of the characteristics of these alert messages. They are mainly related to animal specifications. And in the human type of alerts, they are very much related to all of the other topics. So to finish the project, you can move forward to the last, one more. We show a few screenshots of how this labeling tool would work. The idea is that the user logins and choose the language that they want to collaborate with. They see the instructions that they have to mark these translations and define if it's highly accurate or highly inaccurate, or middle brackets. And the idea for this is that in the future, this open source data set will provide like full high quality of, so people can use the highly accurate ones and fix the highly inaccurate eventually, or decide what to do then. You can just move to the last one, and it's, thank you.